Good morning, students. Now I am going to take mathematics class. Last class you have learnt about matrices, introduction part of matrices. There you have learnt about the types of matrices, different types of matrices, then addition of matrices and subtraction of matrices. Now we are going to learn about how to multiply the given two matrices. How to multiply the given two matrices. Now to multiply the matrices, we need to follow certain rule. So I'll write one matrix now. So matrix A equals 2 minus 1 minus 1 3. Now in the last class you have learnt about how to write the order of the matrix. Now here I have written matrix A equals first row 2 minus 1, then second row is minus 1 and 3. So the order of this matrix is, so we'll write here it has 2 rows and 2 columns. This matrix has 2 rows. Rows we know, horizontal we call it as rows and vertical we call it as columns. So this has 2 rows and 2 columns. So for that we'll write the order as 2 cross 2. Now when we say 2 cross 2 matrix or 2 into 2, now this is a square matrix. This is a square matrix. Now how to multiply the two given matrix? Now I'll take one question saying that find a square minus 3a, a square minus 3a plus 2i. A square minus 3a plus 2i. Now, how to multiply that? A square in algebra, we know that a into a, will write it as a square, or x into x, will write it as x square. But here in this matrix, how we are going to multiply? There is a condition to multiply this. Now this we know it is 2 into 2. Now here we are asked to find a square. A square. Now a square means a into a. We are going to multiply the same matrix 2 times. So to multiply the same matrix 2 times, now I write this as a square is equal to a into a. So one more a I am going to write here. 2 minus 1 minus 1 3. So always we write first rows then columns. So when we write, how we are going to read is 2 minus 1. So always we follow that rows and then first row then second row. Now we'll write the order of this matrix also. Now the order of this matrix already we know. Even this has 2 rows and 2 columns. 2 rows and 2 columns. Now condition for multiplying the two matrices, what we are going to do is, now this is our first matrix. Then this is our second matrix. So in order to multiply, condition is the number of columns in the first matrix. The number of columns in the first matrix is same as the number of rows in the second matrix. The number of columns in the first matrix is same as the number of rows in the second matrix. Then we are going to multiply those two matrices. Then we are permitted to multiply those two matrices. So to multiply the matrix, what we do is, in order to multiply, we are going to check the number of rows in the first matrix is same as the number of rows in the second matrix. When those two are satisfied, then we are going to multiply the matrix. Then how we are going to multiply this matrix? So in the last class you have learned about the addition of two matrices. So for the addition of two matrices, so there we are going to check the condition is the order of both the matrices are same. 2 cross 2, here also 2 cross 2. Then we are going to add the corresponding elements of both the matrix, or to get A minus B, to subtract one matrix from the other. Again we will check the compatibility, saying that 2 cross 2 matrix, when the order of the matrix is same, then we are going to subtract. Now to multiply, our condition is, we are going to check the number of columns in the first matrix is same as the number of rows in the second matrix. Then we are going to multiply this. How we are going to multiply is, first matrix will multiply row wise. First matrix will take row, then second matrix will take the column. So we'll multiply row into column. First matrix always we take it as row wise, then second matrix always we take it as column wise. Then how we are going to multiply? First row, now to multiply this, first row into first column. First row here it is, first element is 2, then here first column, first element is 2. So there we write 2 into 2, 2 into 2 plus, then first row second element here it is minus 1, then here first column second element is minus 1 plus minus 1 into minus 1, minus 1 into minus 1. Now this first row first column will become the first element of the resultant matrix. Our resultant matrix is A square. So first row first column will become the first element of the resultant matrix. Then first row, then second column. Then again we follow first row with second column. So that becomes the second element of the first row. First row second column is 2 into minus 1. So here first row first element is 2. Then here second row second column first element is minus 1. So 2 into minus 1 plus first row second element is minus 1. Then here second row second column second element is 3. So then here we write minus 1 into 3. So first row second column will become the second element of the resultant matrix. Second element of the resultant matrix. Then next first row here in the first matrix, from row wise we multiplied both the columns of the second matrix. So thereby we are getting first resultant matrix first row both the elements, first element as well as the second element. Next we'll multiply second row with first column, second row with first column will become resultant matrix second row first element. So second row first column is, second row here it is minus 1 into 2 plus 3 into minus 1, 3 into minus 1. So here we are multiplying next second row with first column. Second row with first column here minus 1 into 2 plus 3 into minus 1. So that becomes the second row first element. Next second row with second column. Second row with second column is minus 1 into minus 1 plus 3 into 3 plus 3 into 3. So now we have multiplied both the matrix A into A. Usually in algebra or in regular maths we say A square, or 2 into 2 will write 4. But in matrix we are following this number of columns and number of rows. If the order number of columns in first matrix is same as the number of rows in the second matrix, then we are going to multiply the matrix by using first matrix row system, then second matrix with columns. Now we'll simplify this. Now here 2 into 2, 4, then plus, here we have minus 1 into minus 1. Minus 1 into minus 1 will become plus 1. Then second element is 2 into minus 1 will become minus 2. Then plus minus 1 into 3 will become minus 3. Minus 1 into 3 will become minus 3. Then second row, first element is minus 1 into 2 is minus 2. Then plus 3 into minus 1 is minus 3. So here we are getting minus 1 into 2 is minus 2 plus as it is, then 3 into minus 1 is minus 3. Then second element here is minus 1 into minus 1 is plus 1. Then plus sign is there here, then 3 into 3, so we are getting 9. Now we'll simplify further. On simplifying further, now 4 plus 1, 5, then minus 2, then here plus into minus will become minus, minus 2 minus 3 is minus 5, Then here again minus 2 plus into minus will become minus. So minus 2 minus 3 again we are getting minus 5. Then here 1 plus 9 is 10. So on multiplying the two matrices of the same order 2 cross 2, on multiplying the square matrix A square, we are getting the resultant matrix as first row 5 minus 5, second row minus 5 and 10. Minus 5 and 10. So this is how we are going to multiply the two given matrix. So the two given matrix here are taken the sum to find the sum as A square. So I am multiplying the same matrix twice. So for the multiplication of two matrix, our condition is first we are going to write the order of the matrix. So when we say the order of the matrix is how many rows and how many columns, so that we write for both the matrix as our subscript. We'll write both as subscript. Then we'll check the condition. Number of columns in the first matrix is same as the number of rows in the second matrix. Then it is permitted to multiply. Then we are going to multiply. So row first matrix always we take row wise. We'll multiply both the columns of the second matrix. That becomes first row first element and first row second element. Then second row again will multiply with both the columns of the second matrix will become second row first element and then second row second element. Then we'll simplify our regular simplification. So thereby we are getting A square is 5 minus 5 and 10. Now here we have done the first part. First part A square is 5 minus 5 and 10. Then 3a in the last class you have learned about scalar multiplication, scalar matrix multiplication. So to get that scalar matrix multiplication in algebra we write suppose 2x, 2 is the coefficient for that variable x. In the same way in matrix here instead of saying that coefficient we use the word scalar. So there they are given 3a. It means that whatever the elements of there in matrix A, each element we are going to multiply by 3. In algebra we say 2x, so 2 will become the coefficient for variable x. But here in matrix we are using the word as scalar. Now we'll multiply this. 3a is 3 into our matrix A is 2 minus 1 and then 3. So 3 into A, so it means that each element of this matrix we are going to multiply by 3. So on multiplying we'll get 3 2s are 6, then 3 into minus 1 is minus 3, then 3 into minus 1 is minus 3, then 3 into 3 is 9. So this is what we call it as scalar multiplication. Scalar multiplication means whatever the coefficient they are given here, in that we call it as scalar. Each element of the matrix are multiplied with that number. So 3a we are going to get it as 6 minus 3, then minus 3 and 9. Then here they are given 2i. 2i is nothing but we know what is I. I stands for identity matrix. Now we have whatever the matrix order they are given, type of matrix they are given for A, in the same way we are going to write this identity matrix. Identity matrix again they are given 2 here. 2 is the scalar multiplication of the identity matrix. So for 2 cross 2, so 2 cross 2 matrix we are going to write the scalar as 1 0 then 0 1. So the identity matrix of order 2 cross 2 is 1 0 0 1. Then here they are saying 2i. So to get the 2i, each element of this identity matrix I we are going to multiply by 2. On multiplying this we are going to get it as 2 0 then 0 2. So each element of this matrix we are going to multiply by 2. So now we found out the value for what is A square on multiplying matrix. A square is first row 5 minus 5, then 3a we are getting as 6 minus 3, second row minus 3, 9, then 2i, identity matrix, so 2, 0, 0, 2. Now we'll compile all to get our required answer, required result. So finding therefore a square minus 3a plus 2i, a square minus 3a plus 2i, so which implies a square is 5, first row minus 5, then second row minus 5 and 10, minus 3a, 3a already it's there here, 6 minus 3, then minus 3, 9, then plus 2i, plus 2i we have found out here, so 2, 0, then 0. Now here in the last class this you have learned how to do the addition operation, that is addition and subtraction. So now we'll check the order of each matrix, the whatever find the matrix we found out, order each one is 2 cross 2. This is 2 cross 2, 2 cross 2, then 2 cross 2. When the order of all the matrices are same, then we are going to do this necessary operation. Here they are given minus, then here they are given plus. It means that we are going to add and subtract the corresponding elements. So to add and subtract the corresponding elements, so first element of the first row in all is 5 minus 6, then plus 2. 5 minus 6 plus 2 will become the first element of the resultant matrix. Then the second one is minus 5, then minus into minus plus 3, then plus 2. So we'll rewrite this minus 5, then minus into minus plus 3, then plus 0. So the second element of the second element of the first row. Then next second row elements we are going to equate the corresponding elements. So minus 5, minus into minus plus 3, then plus 0. So this elements we are going to equate. So it is minus 5, minus into minus plus 3. Here minus into minus will become plus 3. Then here it is plus 0. Then last one is the second row, second element. So 10, this 9 and then this 2. So we'll equate the second row, second element in all the matrix. So this is 10 minus 9, then plus 2. Then further we'll simplify this. On simplifying, now 5 plus 2, 7, then 7 minus 6, so 1. Here minus 5 plus 3, minus 2. Then here it is 5 plus 3, minus 2. Then here it is 5, 10 plus 2, 12. Then 12 minus 9 is 3. So on simplifying the given expression a square minus 3a plus 2i, a square minus 3a plus 2i. So what we are going to get as first row minus 1, 2, then minus second row is minus 2 and 3. So this is how we are going to simplify the given whatever they have asked here, expression a square minus 3a plus 2i. So first what we have done is we have multiplied both the matrix A into A. On multiplying, our condition is number of columns in the first matrix is same as the number of rows in the second matrix. Then we are going to multiply row wise. First matrix row wise will take, then second matrix will take column wise. Then minus 3a. Minus 3a is scalar multiplication. Each element of this matrix A we are going to multiply by 3. Then 2i. I is the identity matrix. Whatever the order they are given for matrix A here, this also we are going to take the same. So it is 1, 0, 0, 1. Then we'll write all that. Then we'll do our regular operation, addition, subtraction. So thereby we are getting result answer for this expression as 1 minus 2 minus 2 3. Now today we have learnt about how to multiply the matrix and how to find the solution for the given expression a square minus 3a plus 2a. So next class we will continue further. Thank you.